are based on his current position, or we'll go to the spot based on his final resting position, depending on what's happening. So, and the way we're determining the spots is pretty simple. All we're doing is getting the current squad rank. I'm not sure where my whiteboard is. Maybe we can do this with, here, let's just do this. Let's just get this. Okay, so we're just gonna use these as our whiteboards. So we've got, right now we have 8 people in our squad. So what we want is we want 2 rows, and we want them to be 4 people. What we want to do is, if this is position 1, that's going to be, well, let's make this simple first. Okay, what we're going to do is we're going to offset it. So they're all going to follow in a position like this, because I don't want to worry about subtracting this off. So the first one, the squad rank mod 4. Let's see if we can do a mod. We can. Mod 4. I believe that is going to be 1 mod 4 is 0 with 1 left over, I believe. I think that's the math works. Hold on. 1 mod 4 is 1. 2 mod 4 is what? 2, that's the leftover. Maybe it's not mod that I want. Maybe we just want mod is just the remainder. So the interesting thing is the remainder is what we want for their position left to right. Okay, so that is going to be the X value. And then I think if we just divide this by 4, let's just try this, divide this by 4. And I believe an int divided by 4 is not going to give me an int, so it should give me 0. Let's just see what this does. Okay, so this is left to right, and this is front to back. So we're going to take our current squad rank, mod it by, divide by 4, and then we're going to multiply that by -200. Actually, you know what? Let's duplicate this so we don't lose this. We already know what we're doing with that. I don't want to lose this, so I'm just going to copy this up here. Okay, and if you are just joining us and you're asking questions, I'm not ignoring your questions. I had to pre-record this one. So just throw your questions in the chat down below, and I will answer those in the next live stream or reply in the chat. For some reason I missed one of my copies when I did that. Alright, so let's copy this. I see. We need to convert this to an integer. And we'll feed that in a second. So we're going to take our AI. Okay, so theoretically, this divided by 4. Okay. And we're going to take our actor location, normalize times 200. Interesting. We don't want to do just times 200 here. What we actually want to do is we want to make this a vector. So what we want to do is that one portion of the vector, let's see here, that times 200, that is going to feed, this is front to back. Then let's try the same thing. Let's just multiply. So let's duplicate this. And we are going to multiply the 200 again. And this is going to be hold on a second. That's gonna, one of these vectors is gonna be back, and then I want to add in an over. So I can't just do that because I need the perpendicular value. So this is gonna be straight behind. How far behind? And then is it the, I need the vector that's perpendicular. I believe that's the dot product. The dot product, oh no, the dot product will turn to me whether or not they are perpendicular or not. And the cross product, what does a cross product do? What does it do? What does it do? Yeah, that's the one that results in vectors that's perpendicular. So how the heck do I do that? Because what I don't actually know. I know which way this dude's moving, and I know what it is normalized. Cross product. Yeah, that's not gonna help me. Because that's gonna result in a vector that is, oh. What I could do is I could take the vertical one, right? And that's gonna give me a vector that is perpendicular. All right, and then that's the one that I'm gonna multiply by this. This ought to be entertaining. And then that vector times 200. I also need to, I believe I need to do the same thing here. Times 200. And then add these two together. Oh, this seems bonkers. I'm definitely going down a rabbit hole here. So we're gonna add those two together, and then we're gonna take that and we're gonna set that as our location. This is gonna be wild. This is happening if the dude is moving. So I don't even know what they're gonna do with this. All right, the lead is moving. Okay, then they're gonna go get in line because that's what they're doing when he's not moving. So the first four, okay, he's not moving long enough. So we can't really see what's happening. So let's do this. Let's draw a debug sphere. And let's just see where this is showing up. This ought to be entertaining. We can make it 50 so it's not too obnoxious. Do a duration of 1 and a thickness of 1. Then at least when he's moving, we can see what they think they're supposed to be doing. Oh, look at that. I mean, it kind of works. Holy cow. That's pretty good. I think, okay. Holy cow. I did not think I was gonna get that math right on that first shot. Okay, so if this is right up here, we kind of need to do the same thing down here. And the difference is down here. We do need the blackboard, so we're going to feed into here. No. Oh, it's just a blackboard? Oh, okay. Fine. And then what we're going to do is... we don't need this draw debug sphere, right? We don't need that. This is location. Okay. So this is going to be the move to location of the leader minus the previous. So that's the vector. Okay, that's fine. So that's a vector. Okay, so here's where all the negative. All right, we're just going to make sure we plug this in the right place. So we were plugging this in, we were adding it all in here. So I think all we want to do is add in this instead. Oops. Wait a second. That's the vector minus the previous location. That's where we're starting from. What is it feeding into here? The velocity feeds into the normalized, which goes into cross product. So the vector feeds into the normalize, which goes into the cross product. Okay. What else is in that cross product? And that gets added back to whatever that gets added back to. So this should be theoretically here. All right. So let's see if they settle in. So it'll be interesting. Okay, I can't tell if this is working. I think we need to draw some more debug spheres. And we also need to change this song. Alright. So we're gonna draw. Just check our levels. Yes. Okay. We're gonna draw a debug sphere here as well. So let's draw this. Actually, we can just put the draw. Yeah, we can just draw debug sphere. Okay, and the center is going to be here, and our duration is going to be 1, and our thickness is going to be 1, and we're going to set this to 50. Let's go. Okay, so let's figure out where our lead is. That dude just got sent. Okay, so this guy's our lead. But these two, these are all on top of each other. We're missing something. Because there should be a second row. And those are all just sitting right on top of each other. We don't have a second row. So let's see if we can figure this out. So we're getting our squad rank. We're dividing by 4. This is definitely missing a connection. That can't be 0. Dividing by 4, that should go into the negative 200 molt that we had before. Wait, what? Okay. Just trust that what we did before was right. See what happens. Okay. That looks a little more promising. Look at that. Warm up, people. We have got to figure out what that physics simulation problem is. That's pretty cool, man. All right, he's having a problem getting to that spot, but that's okay. There's gonna be some kinks. Okay, so there's a couple of problems here with this particular formation. For the most part, kind of cool that dude climbed up on the ledge to get to his spot. It'll be interesting to see if he can get down. Nope, stuck. It's kind of cool just to sit here and watch them move. All right, we're gonna call this our second formation. I gotta say, I was pretty surprised at how well that math went for a first shot. Let's see here. Now here's the trick. What was I talking about before? We got a couple problems here. All right, right now, if you notice, let's duplicate this a couple times and just show you what I'm seeing. We've got our enemies, and they're all trying to line up like this, and there's 8 of them. So what's happening is, and this may not be a bad thing, right? It kind of depends on what we want to do. All right, so what's happening is this guy right here, in fact, let me just make him a different color. This is our leader. And what's happening is all of our squad followers are falling in line with the leader. It's a little different than what we talked about where the leader was out front. So let's just double check that that's what we're seeing. Yep, so the blue one's the leader. This is the leader in the top left corner. He falls in place and everybody falls in with him. But he's in line. He's in the ranks, which is okay. It's just a different formation that I was originally talking about. But it's cool. So we can call this a formation. All right, so let's see here. So what we want to do though is, so right now these are our formations. We got this one. We got single file, which is pretty straightforward. Drawing with blueprints, right? Okay, and then what I'm thinking is, I think we could probably make this guy, right? Where he's, basically they stack behind in rows and rows and rows. So to do this one, what we need to do is, let's comment this though. All right. So, and you know what? I really want to make this a function. So let's do, in both cases, what we're doing is after the 200, this value feeds into the plus pen. The plus pen. Okay, so let's write a function called getFormation real quick here. Where are we? We're in form up. Yeah, we can write it in here. Let's get ball in position. Okay, and it is going to take as an input it's going to take a position and a vector, which are both technically vectors, but let's just do this. 1, 2, position. Oh, or start, no. Anchor position? Yeah, let's call this anchor position. Anchor position. And we'll call this the facing vector. And then these are both going to be vectors. That did not click. And then we need an output, which is going to be our Boolean position. Okay, let's compile that. All right, and then what we're going to do, let's just disconnect this. And let's steal all of this stuff. Oh, you know what? We want a position type too. We need a formation type. So for now, let's just get our stuff. Let's see here. So we're going to, first, let's recreate what we have just to be safe. Okay. So we're going to take all of this. And how much of this are we going to take? Sure, let's take, now we'll feed that in as that. Take this. And that is going to return us all of these. Okay, cool. So what we're going to do is spread this out a little bit. And that was just Control C, Control V. Okay. So our actor position is going to feed into the plus at the end, which is here. Okay. And then our facing vector is going to feed into both our cross product and our negative 200. Negative 200 and our cross product. Alrighty. And this output is going to be our final position. Now, there's a couple other things that we will tweak with this, but let's just get this and make sure this is working. Okay. All right, this all looks fine. So let's compile and save this. Let's save our Blackboard just to be safe. And then what we're going to do here is we are going to call get Boolean position. Okay. And I'm going to make this a pure function. Am I not pure? Because I don't need to do it inline. So let's get Boolean position. All right, and what we're going to do is we're going to disconnect these guys. And our facing vector is going to come off of this. And our location is going to come off of this. Now what should happen here is if we do the same thing down here, we're going to feed this into our setting of the position. Yep. And our this is going to be our anchor position. And our facing vector is the normalized version of this, I believe. Is that right? Theoretically, yes. Okay, so if we set up our function right, we should have the same behavior. Those are the positions that it's drawing, but he moved. There they go. That looks pretty good. I'm not upset by that. We're just gonna give him a chance to settle. Man, we have got to fix that. All right, they finally, oh, they almost made it. He didn't stop long enough for them to get there. And the one dude keeps getting bounced out because of boundary stuff. But as you can see from our spheres, they are going to, theoretically, they are trying to get to the right position. Our math is not wrong. There they go. They got it. And there's going to be some things that we can do to improve this. Okay, cool. So that's great. So our function is working. Now let's fix our function. Let's add. Okay, this is going to be. Actually, this is going to help us clean this up quite a bit, I think. Okay. So let's see here. All of this is going to be, what are we going to call this? Civil War seems like a weird name for this. Rows, columns and rows, rows and columns. Columns? We'll just call it column form. Column. Okay, so let's comment this as this is going to be column. All right, now let's do the same thing, but this time we're going to make single file. And actually what we want to do is let's variabilize this if it's not already. Promote to local variable. And this is going to be our final fall in position. Okay. And then what we're going to do is we're going to set that here. Yeah, we're going to set that with this. Okay. And then when we're done, we'll come out and finish. All right. So, but right now we're not actually going through here, and we will be in a second. So anyways, this is columns. Now let's do single file. Now single file should be the same thing only. So let's restore our single file. This is our single file. Should just be this. And single file should just be this. Let's just double check that. It's so cool to see. Oh. Wait, why is it even calling that? It's not using those. Hold on a second. That's getting the fallen position, but it's not actually using that. So how in the world? Oh. Okay, hold on. Maybe that wasn't the right one. Maybe this is single file. Let's see here. Undo. Okay. When the lead was moving, the position was right. That was pretty cool. For those of you, these guys are getting in position. Anybody who's joining us right now, if you're asking questions and I'm ignoring you, I'm not sure if I was able to hop in the chat or not, but I pre-recorded this one because I had to take care of some stuff out of town. So here goes our dudes. They are in single file. I don't know where they're going right now though. We definitely broke this. So I'm not totally convinced we have this right. We need to get back to single file. So single file should just be the control point actor position normalized times the squad rank plus the original position. So that should set the location. Then down here, we should get the move to location vector normalized times negative 200 times that plus the move to look. Yeah, no, this should be it. Oh, hold on a second. We definitely messed that up. Okay, so it's going to be previous look at minus the vector times negative 200 squad rank times that. That's going to get added back into the move to location. So this should be single file. All right, let's double check that. Give them a chance to fall in. Look at those spheres showing up in a nice line. Perfect. All right. That is single file. And what we want to do is we want to pull that into our function. So let's do this. Let's get rid of this so we're not confusing the issues here. If it's not connected, I can delete it. This is connected. I'm going to keep that for a second. So actor location normalized. So it should be this. Form up task. Alright, so this is going to be single file. And the single file is going to be actor location is going to feed into what we're adding to, and the velocity is going to be the other one. So this is going to be the actor location, should feed into the plus sign, and the velocity, which is our facing vector actually, is going to feed into here. And we can add these together in a different order, won't matter. That seems awfully simple. So let's just try it. The plan is that theoretically this should be the same thing as single file. I know it seems a little too simple, but let's just try it. All right, so single file. So we're going to get fall in position again, but here we're going to feed this in as the anchor position and the normalized as the facing vector, and then that is going to feed into our position. And these are the same. That's what we want. Okay, and then down here, we're going to do the same thing. All right, and what we're going to do is the normalized. This should feed into our facing vector, this should feed into our anchor position, and this should feed into our location. So theoretically, we should still have single file. Let's see. Looks like we have a giant beehive, not single file. Oh, there's no way that works. Dude, we're missing something huge here. It doesn't even factor in. What is this, 0? Look at this 0. That doesn't help us. That 0 needs to be multiplied by our squad rank. Maybe we were missing something. All right, now let's try. Look at that line. Looks good. Perfect. Now when the squad lead starts moving, they start moving. Looks good. Okay, cool. So now we have single file. So that is going to be this guy here, which is way simpler than our other one up top. So we can comment this as single file. All right, and then the last little bit that we want to do here is we want to select which one we want. So let's do this. Let's, on one of our inputs, let's create a formation. Sure. And can we make an enum out of this? Enum. Can we make an enum on the fly, or do we have to define it first? Enum field? Default value. Nope, that's not what we want. Enum. I guess we can't create one. So what are our other variable types if we don't use enums? We could use it's kind of a bummer because these are all predefined. I guess we can't. Oh, look at that. We have a strategy type enum. What's that all about? Let's take a look at that. Strategy type enum. Attack, defend, or none. Where's that live? You know what? Let's just make one of these. Let's duplicate this and call it formation. Formation enum. And then in that formation enum, let's edit this to single file. Single file. Let's call it rows. With leader. And then we'll call this rows. And then we want another one that's going to be flying V. I know you guys love that. We're going Mighty Ducks on this. And then let's do one more. Let's do random. That one should be pretty easy. And let's save that. And then let's go back to our form up task. Let's change this to our formation to be formation enum. Okay, we can kill that, compile this, and then let's just select. Is there a select on there? Select. Maybe it's not select we want, maybe it's switch. SIWTCH. Enum formation. Here we go. This is what we want. All right, so what we're gonna do is we're gonna do this time. What we're gonna do, same thing again, but we're going to switch it up based on which enum is passed in. So if they come in single file, we're going to come and we're going to set this one. Okay. If they come in, should be pretty straightforward at this point. If they come in rows with leader, we're going to set this one. And they're all just going to feed out to the out. So we're just going to be setting these based on which enum they pick. And maybe what we want to do is add these as local variables so we don't have all these lines going everywhere. So let's promote this to a local variable. And we're going to set this as the anchor position. It doesn't like that because I've already got that, so maybe I don't need that. So can I just do, maybe I can just do anchor position. Oh, sweet, I can just do that. All right. So the anchor position feeds into here, it looks like. That's great, that cleans that up. And then it also feeds into here. Let's copy that and feed this into here. Again, cleaning up all these little noodles. And then our facing vector, which is also sometimes our velocity vector. We're gonna feed that into here. I like how in functions they do this automatically. I wish they did that. I wish they did that for the other stuff too. Okay, so we're going to take our facing vector and feed that into there. And then we're also going to feed it into here. And that should get rid of this. Okay, so all this comes in so much cleaner now. And we can even flop these so our lines aren't crisscrossy. Not like that though. These will be upstairs. These will be downstairs. Switch this down. Cool. Okay, pretty straightforward. So now, if we run the exact same test again, and this time what we do is we can get rid of this, 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 this. And we're getting our fall-in position as single file and single file. I'm just going for broke here, deleting all of this stuff, and we're simplifying it. So we're in single file mode at this point. And we have greatly simplified a lot of this stuff, which is great. Okay. So let's go back and double check this, compile, save, just because we don't want to lose all that. And then let's just go ahead and play. Do we get single file? Yeah, looks like we do. Everybody's trying to fall in. So we're definitely starting to get close. I'm hoping we get a chance to do flying V now that we have the setup. But let's just do one more test here. Our single file's looking cool. Yep, totally cool. Okay, so now let's just double check and make sure that our rows with leader looks correct. You know what's interesting? Oh gosh, this is actually kind of cool. Actually, I just realized something that we can do. Check this out. All right, so this should be rows with leader. It looks like it is. Where's our leader? Yep, perfect. So let's see where he goes. As they try to move, if he can move, they're going to try to fall into rows with leader. Totally working. Okay, now, here's the interesting thing. I just realized something we could do. We can, while they're moving, in other words, if this velocity is greater than 0, we can go single file. And then once they get into place, then they go rows with leader. So let's just test that. So yeah, they're going single file, cool. And then if they didn't get bounced around, they fall in place when they get there. Oh my God, that's kind of cool, man. Come on, you gotta admit, that's kind of cool to see them doing this stuff. All right, for anybody who's joining us, if I'm not answering your questions, not because I'm ignoring them. I actually had to pre-record this one. Hopefully I'm hanging out in the chat just to see how it's going. But that dude just got sent to space, and this is just kind of cool. This is all working in a really fun way now. All right, so let's compile and save this guy, and let's make a couple more formations. I think random should be pretty obvious. What we're going to do for random is we're basically going to take the anchor position, and let's do that. Let's make this a little smaller. Let's take the anchor position, and let's get navigable, get random location in navigable radius, get random reachable point in radius. Let's try the first one, and let's say the radius is 500. And what are these filters? I'm not gonna worry about the filters. Yeah, we'll stick with none for now. Radius 500, and what we're doing is, if this is random, we're coming in here and we are going to do this. We'll set this to the value. Cool thing is we don't have to keep doing this. We can just do a return node right here. Keep it even cleaner. Just like this. Okay. So if we come back to our event graph and we change these both to random. We'll do random. And then when we play, they should all go to random points within 500 units of the leader. And you can kind of see all these white spheres bouncing all around. Now, the one problem with this is those random points are going to be changing. Right? So that they're never actually settling. And that's one of the problems with the random function. So we may have to find a different way to do random. Right? We may have to check to see if we already found a point or something. So we'll have to do something for that. Could be interesting. And that may be something that we can do with like a seed, right? Rather than, it doesn't look like we have a seed option in here. Random vector, random seed, nope, random location. Yeah, so we're gonna have to revisit random, and I think that one is actually now gonna be the hardest one because of that. So before we chase that one down, let's see if we can tackle the flying V. So all we have to do to tackle the flying V is figure out the math. And the math, do we still have our pretty diagrams? We do. So the math for the flying V is going to be like this, right? So this was mod 4. This is going to be mod 2, or divided by 2, I believe. Yeah. This is going to be mod 4 was how many wide it was. So this would be mod 2 for how wide it is. And then this is going to be Oh, that's interesting. Okay, so this one is a little bit different simply because what we need to do is, it's probably easier if we come straight back, and if we are, we can basically, what we can do is we can look at this as, this. There's gonna be one, that's 3 unit. This is 1, 2, 1, 2, 3. So this is 5 units, I believe. Hold on a second, I need to count this. And I'll show you what I'm thinking here in a second. There's gonna be 1, 2, 3, 4. 1, 2, 3, 4, 5 units. So then this is going to be 1, 3, 5, 7 units. It should be 1, 2, 3, 4, 5, 6, 7. Yes. 7 units. So 1, 3, 5, 7. It should basically just be that for each one. So this is going to be mod 2. They're all going to be mod 2. But it's going to be divided by... No, they're not going to be mod 2. The multiplication changes. Okay, so let's go. Let's see if we can figure this out. 1, 3. Remember 1, 3, 5, 7. All right, so what we're going to do is we're going to take our... let's just get this as a number that we need. And then we need our anchor position. Okay, so we're going to take, we have our anchor position and we also need our facing vector. All right, so what are we going to do here? We're going to take each, okay, so this is going to be mod 2. That's going to be how deep it is. Okay, so let's just take this mod 2. And then that's going to feed into the cross product of the facing vector, just like we do here. The cross product of the facing vector. Wait, how does that feed into that? Multiplication. Wait a second. Facing vector cross multiplied by mod 4 feeds into the minus 200. Facing vector oh my goodness. I don't know why I can't see this, probably because it's late and my brain is fried. Mod 4 times the cross product. Let's just multiply this times the cross product. Okay. What is that doing? And then we're going to multiply that by the 200. Not this facing vector. We're going to multiply that by the 200. So it's going to give us how deep it is, right? And then that is going to get added to divided by. Oh, this is interesting. We're dividing it by hold on a second. Mod 2, that's left to right. This is how deep they are. I had that backwards. So this left to right not correct. If we divide this by 2, divide by 2, that's going to get how deep we are. That division is going to get multiplied by the facing vector times the 200. Okay, that should be how deep it is. Okay, and then that is going to feed into an add. So this is going to get added to something. And what we wanted to get added to is not what I have here, because what I have here is going to be basically 2 rows deep. So that's not what we want. What we want to do is we need to figure out, because remember we did the 1, 3, 5, 7, 9. So when we were looking at this, when it's 1, it's actually 3. 1. So 1, 2 is 3. 3, 4 is 5. 1, 2, 3, 4, 5, 6 would be here. So this is 1, 3, 5, 1, 3, 5, 7. So 1, 3, 1, 2, 3, 4 is actually 3, 5, 5, 6, 7, 8, 9, 10, 11. 11. 1, 2, 3, 4, 5, 6. 6 is actually not 7, I don't believe, because if we do this, pretend these are just filling the spaces. Maybe it is 7. 1, 2, 3, 4, 5, 6. Yeah, it's 7 wide. So 6 is 7. 2 is 3. 4 is 5. 4 is 5. So one, 2, 3, 4. Okay, 5. Oh, interesting. It's a little more entertaining than that. So there's a couple different ways we can approach this. What we can do is we can say, how far are we subtracting or adding from center? Or we can pretend that these are all going to line up like this initially. And then what we're going to do is, depending on the row, subtract off how many we're supposed to. So for the first row, we subtract off 1. For the second row, we're going to subtract off 1, 2. And for the third row, we would subtract off 1, 2, 3. Seems like a pretty easy way to go. So let's see if we can get this right translated flying V first. Okay, so to do that, this is 3, 5, and 7, right? So 1, 2 is 3. So basically, it's the mod 2 mod 2 gets us the remainder. Mod 2 Okay, so if mod2 is 0, can we do this? I don't know if we can do this. So if mod2 is true, then we know we're looking at a odd number, right? And if we're going to get an odd number, what we want to take is the rank. Ooh, the rank plus 1. Yes, the rank plus 1. Let's try that. So if that's going to be the case, we're going to take the rank plus 1 and multiply that by the 200. Oh man, this is wild. My head is in some weird vector math space right now. So if that's true, this is what we're doing. Okay, and if it's false, what we're going to do is we're going to assume it's all 1. Right? We're not going to add it, it's going to be 0. So if it's false, we're not going to do anything, it's just going to be 0. So rather than this, what we're going to do is we're going to take the cross product. We don't need to worry about it. But let's just, for ease of brain thinkings, let's do that. Okay. So that's where we go if it's false. Wait a minute, what just happened? Oh. Hold on, undo. Alright. Okay, so this is false and that's true. And what we could do, can we multiply by a Boolean? And let's just get this working with normal math before we figure that out. So if that's the case, then depending on which one, that is going to determine what gets added back in. And we are doing this for flying V. So what we'll do is we'll set the fall-in position to be equal to this. And for flying V, we're going to come down here. Okay, we're fading fast. Snap out of it. All right, so flying V, we're going to do a Boolean here. Control drag this over. And the Boolean is this guy here, which we've already got. Okay, and so if it's true, what we're going to do is we are going to set this final position to be this. And if it's false, we're going to set this final position to be this. And then we're going to finish. Can I have everything go in there? Nope. I cannot. So that's fine. We can do 2 different returns. All right. I'm not super optimistic about this, but let's just see what flying V does. So that'll be interesting. Now I'm not expecting this to actually be the flying V that we were looking for. because we did not do the subtraction to get it all to go back. We'll do that in a minute. Let's just see what this even does. All right, our leader is going. The heck? I don't see any spheres, do you? I do not. So these are both set to flying V. This is flying V. That's the fallen position. You know what? We should draw this debug sphere no matter what. So to do that, we're just going to do this. Does that work? I don't think that works. Kind of works. Because what we can do is we can come in here, and then we can do this. Set this as the center. So it should draw spheres while he's not moving and while he is moving. So the lead's moving. Either all of our spheres... Ooh. They're all under the map. Interesting. It's not what I was expecting. So let's see if we can sort that out. So in our flying V, what we're doing is we're getting the facing vector and everything we were doing before. Okay. Oh wait, we're not adding in our anchor position. Oh, well, we done messed that up, didn't we? So our anchor position needs to be added in at the end. Yeah. We're sort of missing that. So this is our facing vector divided by 200 divided by 2 times our facing vector. What's this? Why are we adding 1? Oh, because that's the distance over. Our facing vector, hold on a second now. What is happening? Our facing vector times 200 times that. This is going to be our facing vector. Times 200. Okay. That gives us a distance. And then the divide should give us how deep the rows are, right? And the mods give us left to right. Yes. So we're going to divide by 2 and multiply that by that. Okay, so we're going to divide by 2 and then we're going to multiply it by that. I think we can do this divided by 2. Multiply that in. Okay, and then we're going to take that and we're going to add in everything we did plus the anchor position. So we're going to take that, we're going to add in the cross product stuff, and then we need our anchor position. Plus the anchor position is going to go into here. So we're going to take this, we're going to add in the anchor position plus the anchor position And that is going to feed into here. Okay. So, all right, still not convinced that this is going to look right, but let's just see if the spheres are even on top of the map now. All right, the spheres are at least on top of the map. Oh, Nelly. Actually, that might be right. The first three are straight in line. The next two are 1, 3, 5, and possibly 7 times 200 away. I mean, wow. Okay. So then all that has to happen is we just have to slide them over, and then we should have a flying V. Can't believe this is working. This is awesome. Okay, so let's go back here. All right, so now what controls left to right is this cross product bit. And in the case of this dude, we're multiplying it by 0. All right, and that's why they're straight behind them. And then we're adding in from the original. Now, what we want to do is we actually need to change this 0. Because if we go back to here, let's figure out this math. The first row, rather than being, we want to take the entire row, everybody who's in it, and subtract off 200. The second row, we want to subtract off 1, 2, 200. Is that right? And the third row, we want to subtract off 1, 2, 300. Okay, that seems a lot less crazy. So the first row is going to be this number divided by 2. Isn't this the same thing as changing this number? Instead of multiplying by 200, we want to multiply by, well, let's just take this cross product, okay, and multiply it by this number. Let's just take this and multiply it by the result of this guy, okay, and then we're going to use that after we do the multiply here, and we're going to subtract off that result, and we're going to feed that into here. Okay, and then for, if it's true, it's the same thing. When we determine our 200 value, we're doing all of this. We're going to do the same thing. We're going to take this value times the cross product, and we're going to subtract that off. So we're going to subtract that off, and we're going to feed that into here. Oh man, let's see if this works. Come on. All right. All right, what are we looking at? Yeah, I don't think that's working. Why isn't that working? Like, that's clearly not, that doesn't look any different than what we did before. So this factor is going to be 0. 0 times negative 200. Oh, I think we want to divide this by 2, and we want to plus 1. Plus, convert this to an integer. Plus 1. And the value that we're multiplying is this. because then it will start not at 0. Okay, where's our lead? Whoa, whoa. Man, that doesn't look any different. Actually, it is a little different. I think it's a little different. But the thing that's interesting is how far apart these other dudes are. That looks like more than what we bargained for. So hold on a second. The first, like, let's see here. Let's take a look at this. Okay. Squad rank. Actually, let's take a look at that for real, actually. I want to know, do our squad ranks start at 1 or... So that's a leader. Squad rank 1, 2, 3. So our squad ranks are running at... So they start at 1. So 2 mod 2 is 0. So 0 should be false. So the value we're going to get is going to get the facing vector with a cross product of -1. That should give us a sideways value. Okay, and then we're going to multiply that by... Oh, interesting. If we multiply that by 0, then, okay, so let's assume this starts 0 based. So 0 mod 2, what is 0 mod 2? I think it's 0. 0 mod 2 should be 0. Okay, yeah, so that's gonna be, that makes sense. So the first time through here, 0 mod 2 is 0. So that's false. So then they're gonna go, we're gonna take 0, we're gonna multiply that by 200, then we're gonna subtract off 0 divided by 2, which is 0 plus 1. Oh, look at this. When we subtract off, we need to be subtracting off this. Hold on a second. This times 200, I believe, is what we need. This times 200. Okay. See if that gets us back more towards center. That's not what we want. Let's simulate this. All right, where's our lead? Oh, look at that. That is a lot closer. It's not dead on, but it is a whole lot closer. I didn't actually mean to click on that guy. Man, what's he doing? Okay, hold on a second. Let's get rid of this. We don't need this or this. Oops, undo. Or this. Alright, so let's run this again. Simplify this a lot. Okay, this kind of makes a little bit of sense. The only thing that's a little bit weird, I think much like we're doing with the ranks, it is actually including the lead in the calculations, which is why we have a gap over here on this side. It's kind of cool though. Kind of cool. Yeah, it's almost like it's counting the lead as one. So there's a couple things we could do here to make this a little nicer though. So right now, the division is how deep it is. So let's just make them a little bit deeper. And then let's put the spacing between to be 100 instead. This should tighten up our V. Theoretically. It should make it a steeper V. It did. Right? Now the interesting thing is, I'm not convinced when we're looking at this that this is a balanced V. Let's see here. I need to look at that distance. Let's make a change here. Sorry, I was trying to figure out where he does his weight. If we're the lead, let's increase this so we have time to process what this formation looks like. So basically that's the lead. I don't know why these two clowns aren't moving. This looks like 2, 3. Interesting. Let's try something. And this is just a sort of a wild guess. Right now when we're getting our squad rank, what I want to do is I want to subtract 1 from this. -1. Okay. That may actually cause a problem because we may be doing some divide by zeros now, but let's just see. I'm trying to see if that fixes not including the lead. Oh, interesting. Okay, so what it did is it moved this dude up 1. And now the lead's standing next to him. That wasn't quite what we wanted. So we can just plug this back in. So what's happening is the leader, squad rank is 1. So squad rank of 1. Wait, where's the lead? Okay, so there's our leader. The squad rank of 1 is doing the right side first. We wanted to do the left side first. So if we have a squad rank of 1, I think we do actually want to subtract 1 on this. Subtract 1 for the left to right portion of it. And this +1, why are we adding 1 to this guy. Hold on, let's see if that fixes it. Where's our leader? Where are you guys going? Okay, so leader's on the move. So now we have... Now, do we think... We have one, two, three, four, five. Hold on. We have 1, 2, 3, 4, 5, 6, 7, 8 squad members. If we look at our setup, okay, with 8 squad members, this is 1, 2, 3, 4, 5, 6, 7. Let's go down to 7 squad members. Let's try to make this look like it's supposed to. So let's take our enemy spawner and go down to 7. We either need to go down to 7 or up to 9, so we'll go down to 7. So we shouldn't have the one dude trailing in the back now. This first one isn't right because these dudes hadn't spawned when they first set up. So let's see where they go to now. That doesn't look right to me. All right, let's do something here. Let's take out our subtraction. We subtract 0. That should get us back to where we were, where we should have the dude straight behind the leader. Which one's our leader? It's hard to tell which one our leader is with these texts. Alright, so these, okay, look at this. They're not right, right? Because look what's happening is it's going every other road. We have one who's straight behind. And that doesn't, I don't know if that's 200 units, personally. And then, okay, so here's what's happening. Our math is off somewhere. So, let's see here. The facing, oh, okay, because we're doing 300 here. Because we were tightening this up. Let's go back to all 200s. Just to get this, oh, and we had a 200 here. Who knows what that's doing? Let's get this all back. All back to 200s. So we're consistent. Let's see where we are. All right, this is the leader. Nobody's gonna be in line properly because this dude's missing. All right, so here's our leader. And I would say that these are still in the middle. Look, these are between these two. They should be in the exact same line as these other ones. So those are definitely off. And also, look at how far away they are. There's got to be something going on with our math. All right, so we take the facing vector. Okay, we multiply that by 200. And then we're multiplying that by the number, our squad ranks divided by 2. So if our squad rank is 1, 1 divided by 2 should be 0. If our squad rank is 2, oh, this should be, I think this should be squad rank minus 1. Minus 1. And then we're going to divide that by 2. And then that is going to give us the depth. Okay. Let's see if that fixes the depth problem. All right, here's our leader. I'm not totally convinced that that is fixed our depth problem. And also our distance behind our leader is nothing. It should be more than that. Okay, so on the first squad person, we have one. We should take this whole thing, divide it by 2, and then we need to add 1 to it. We need to add 1. The reason we need to add 1 is because nope. The reason we need to add 1 is because we don't want to multiply by 0 for getting our depth. Okay, so now we should no longer have a dude right on top of our leader. This is going a lot longer than I thought it was going to go, because it's one of those problems that I just want to fix. All right. So that looks good. These look to be, every other one seems to be another 200 behind. So our first one's in the right position behind the leader. Our second one is an extra 100 back. Then our third one is the right, and the fourth one, so on. So I want to know what it is printing. Okay, so this number is, all right, so the first, I want to know what our squad rank is when we come in here. It's just, I want to see if it's starting at 0 or 1. It looks like it starts at 1. Okay. So with that in mind, when we come in here, we start at 1. We subtract off 1. That gives us, and we divide by 2. So 0 divided by 2 is 0. 1 divided by 2. What I'm curious about is what this value is. Let's print that string. Print string. Somehow I got caps lock on. And the string I want to print is this divided by 2. Because what I should see is 0, 0, 1, 1, 2, 2, etc. That's what I'm expecting. Except I don't see anything printing. I got that print in the wrong place? I do. Oh goodness. Let's alt this guy, control this guy, drag this guy in, and see what we get. I want to see 0, 0, 1, 1, 2, 2. Oh, it's giving me floats. Shoot. So if it's giving me floats, oh, that's giving me floats. I want to return, I want this to be an int. Can I convert this to an int? Convert into integer. Ooh, interesting. Okay. So I'm going to subtract that 0. Alright, and then if I print that, do I get what I expect? Also, all my formation's going to be messed up now. That's okay, because I want to see Am I getting what I'm expecting? That also makes me wonder if my other stuff is working. Because I was counting on those being ints. 0, 0, 1, 1. I think that's working better. Okay, so now we're going to take that divided by 2. And we're going to multiply that. No, we're going to add 1. So let's add 1. Add 1. And then we're going to multiply that by our distance back. No. Let's convert this pen to an integer. And then feed that in. Interesting. All this pen conversion stuff's new. We didn't have to do this before. Okay. So distance back should be better. Where's the lead? Okay. There's our lead. I believe those dudes are in line now. They look to be in line. And that looks reasonable. What doesn't look reasonable is our left to right distance. That looks like it's really far. So let's take a look. Okay. So all of this is working now, I believe. Okay. And then if we're looking at this modded 2, and then what we want to do for left to right, not entirely sure how left to right is working. We're going to take that value of 1, subtract off 1, mod 2. And if it's false, that means it's even. If it's true, then what we're going to do is we're going to take that, hold on a sec. This is depth. This is all supposed to be left to the right. We take this cross product and we multiply it by one. Oh, that's right. 1. If we went back here, we were saying this is 1. 1, 2, 3, 4, 5, 6, 7. Wait, 1, 3, 1, 2, 3, 4 is 1, 2, 3 is 4. Yeah, so it should be plus 1. So this value plus 1 times that value times the 200, adding in 0, and then we're adding in, oh, we're adding that to our distance back plus our anchor position. That should get our final position. That seems reasonable. Okay. And then if it's false, false should be wrong right now. So if the reason false isn't wrong is because what's happening is we're getting our anchor position, we're adding in our depth, which works, and we're adding in left to right of the cross times 0. That's why that works. Times 200, which is 0. And then we're adding 0 to the anchor position, so we're getting it all straight behind it. Oh, this song does not work at this hour. Okay. So what's going to end up happening here is we should have the straight people behind. Where's our lead? Yeah, so the only thing I don't like is that our first position is so far right translated. It doesn't make any sense. So when we come in here, we get our squad rank of 1. We subtract off 1, which is 0. Divided by 2 is 0. We add 1, and that gives us our distance backwards. Then we come in here, we add 1 to it, which is 2. We multiply that by the cross product of the facing vector. Then we multiply that. Oh, you know what? Let's try this. Let's not increase it by 1. All right, guys, where are we going? That looks a little better. You know, a cool way to test this, to figure out if this math looks reasonable, would be to make those spheres a radius of 100. I think overall, this might be a little better. Okay. And, but we could do that with the spheres. Let's see here, our draw spheres. These are radiuses, so if it's 200 apart, these spheres should be touching. From a unit standpoint. And they should have one sphere between. So that's one sphere. Looking at this. I think that's reasonable. I think that's one sphere between. And that's one more and one more. Okay, cool. Okay, cool. Oh, maybe we're getting closer here. Okay, so now let's add back in the subtraction. Okay, so this is all we need to do for the subtraction is we need to subtract off. We're gonna go by 200. Okay. And it's going to be 200 hold on a second. We're going to take, we basically want to take the facing vector cross product multiplied by 200 times 1 I think it's times this. Let's convert this to an int. I think it's times this. Okay, and we're going to subtract that from this and this. And then that might give us a flying V. Uh-oh. That looks suspiciously V-like. Let's see. Look at that. Oh my goodness. I think that worked. I think that worked. I think we can stop watching TV. I mean, I'd have to go to orthographic view, but I think that's a pretty reasonable flying V. This dude can't get to that spot, so that's why he's not going there. So we're gonna have to add some logic to deal with what happens when they can't get to the spot. He's still not going to be able to get to it, but... Oh, maybe there's navigable radius outside this thing? Oh yeah, he can get there. Cool. Okay, so to recap, we have set up the ability for our characters to form up. We got single file, we got columnar, we got flying V's. This is cool. Now, I think we might use a flying V if they're like defending something that is moving. I think that might be cool. We could also use random. I don't know. It was a fun exercise to figure out how all this might work. Now, because of what we learned in here though, I gotta admit, I'm wondering if we actually have our math correct up top. Because, at least for the columns, this may be returning a float. Oh no, this has an output of an int. So it can't be. Okay, maybe we just missed that step. In here, when we did our divide, we weren't outputting an int, I guess. Okay. I'm not even gonna get any kind of fancy with this tonight. I'm just going to take this whole section and comment this as flying V. Okay, so this is good to go. And random needs work. Did we have any others? Oh, we had rows. And I think all that was the leaders up front. But I'm not gonna worry about that one because the general gist of it is we got all this working. I think the final cap on this would be to be able to specify the formation from the squad leader. So for example, in here where we're getting the formation, when we get this flying V, we should get the formation from, this is the squad leader. So let's go to this blueprint, and in our blackboard, let's create a new variable. It's an enum. It's gonna be a squad formation. And in our squad formation, we're going to key type is enum. We already know that. Enum category. Interesting. Here we go. Formation. Formation enum. Very cool. Let's save that. And then in our strategize, what we want to do is, let's do this. So in our strategize, up here when we're the leader, let's do this. When we decide that we are the leader, squad rank, nope. Squad ID, nope. Squad color, squad ID, B squad lead, true. B squad lead, we're gonna set the value to true. And we're gonna do that if we didn't find a lead. And then we're gonna come in here and squad ID I'm not gonna worry about. Squad color is gonna be determined at the end of this. I guess what I wanna do is right here where we set that it's a squad leader, let's take the blackboard, set value as enum, and we'll feed into here and here, and the key name is going to be blackboard. I believe we call it squad formation. And then back here in our strategize, let's make this guy our key name, squad information, and we're going to make enum byte switch on formation enum. Formation enum. Okay, get number of entries. No, literal enum function. Formation enum. Here we go. And then this is going to be 1, 2, 3, 4, 5. Let's do, is there a random one? Random. Random array item? Nope. So that's a literal enum. And then let's switch on enum. Nope, that's not what we want. This value is random enum formation. Nope. Let's just try random integer. Random integer. And the max is going to be 0, 1, 2, 3, 4. By 4. 3. Because let's just assume it's 0 based. Can I do this? Nope. Can I do random byte? Random byte. Oop. Damn it. Utilities. Select. Here we go. Let's do this. Let's do, okay, we can do this because this is cool because we can, oh wait. Okay, this is cool because what we can do is we can limit this. Let's go single file, row with leader, and flying V. We're not even gonna do random. And then let's make a random integer, random integer. And the max value is 0, 1, 2. So that's 2. And this is going to feed into here. And then what we're going to do is in our form up task, we're going to, from the enemy AI's blackboard, let's get the, we'll get an enum. And we're going to feed it into here. And this is going to be make literal name. Nope. Oh, actually no, it should be the same. Okay, that's fine. So down here, same thing. On the blackboard. Oh, I'm running way out of energy right now. So when we play this now, we should get random formations. So let's see what we get for the first one. That looks like single file. Let's just see though. Yep, that's definitely single file. All right, now what I want to do is I want to go back to this and change this back so that it doesn't take us so long to switch between where we were doing that wait. We went up to 10 seconds. Let's just knock this back down to 4. But this time, let's see if we get something other than single file. That is also single file. Also single file. Still single file. Interesting. I'm either really lucky and need to play lotto, or something is wrong. Yeah, that's not, there's just no way I'm that lucky. let's see here. Strategize. I want to know what this is getting set to. Well, actually, rather than doing that, let's just print this. Print, because the pausing thing is not always great. Nope. The return value. Can I just plug the return value straight in? Yeah, let's try that. Oh, maybe that was the problem. Let's not even print. Okay, that looks like single file again. Yeah, single file again. Yeah, no way. Okay, so let's print this value out. Rows with leader. Okay, that is definitely rows with leader, but that is not what he's doing. So form up is not. Oh, well, wait a minute. What is this sending in? The value is enum, formation enum. And this formation enum is here. Hold on. Print the string. Print the string. Inside, we're going to make it hot pink. So we're going to see what we're setting it to, and then see what we're getting. Oh. How's that possible? We're not getting the right blackboard. You're in the form up task. In the event graph. When we get the squad formation, are we getting it from the squad leader? Here's our squad leader. There's the enemy AI. There's his blackboard. We're getting the value as enum. Okay. And then in the movement side, that's the blackboard, squad leader. Casting that to AI. We're getting his blackboard. And we're okay. So then the strategize task is not setting the leader. This can't be the leader. It's got to be the problem. It's the only thing that makes sense. Oh, hold on a second. Blackboard. B squad lead is true. It comes in here. Checks if the squad ID is greater than 0. Okay. If B squad leader is false, squad can get all the actors of class. Hold on, let's just do this. B squad lead. That's get. That's also get. That's a set. And that's a get. This set's Boolean squad leader is true. And then it feeds into here. Sets the squad ID. Sets the squad color for the character. Sets the base color. Sets the strategy type. Interesting. This is where the integer is. I didn't think it was supposed to do this unless it was a leader. So B squad lead is true. Comes in here, does all of this stuff, sets our strategy type. Hold on a second. The blackboard. It's always single file. Something going on with our enum for our squad leaders, which doesn't make sense to me. Form up task, squad formation, get value. Hold on, enemy AI, control pawn, it gets the blackboard, it gets the squad formation. It's gonna print the string of what it is. Zero. It's a 0. Well, that's part of the problem. So this sets it to 0. I guess this doesn't. Let's try something here. Make value. No. Formation. Enum. Let's try this. Let's just see if we set these to line V always. Nope. So either it's not getting set, or line V is not valid if we use the literal enum. So let's use formation, and let's use byte enum, and let's do line V 0, 1, 2, 3. Try 3. Nope, still getting 0. Either we're not hitting this code as a leader, or none of these are working. Yeah, there's no way, man. There's no way. This doesn't make any sense. Kill this, kill this. Come back here where we set leader as true. Because this is the only place that I know of where this is happening. No way. Is it actually even hitting this? I should only hit this once. There's once. I did. I only hit it once. Okay. So it is definitely supposedly setting this to a value. And then supposedly, let's see here. If we come in here and we get as enum, we connect the string little and we print string on that. Instead, 0.0000. Right to formation enum. There's got to be something I don't single file. There's something I don't understand about this. When we're setting this, this isn't setting properly. Let's do formation. Let's try 3. That is not right. So formation, literal enum, line V, play. No way. We're setting a value of the blackboard by entry category. I'm not worried about. Key type is supposed to be an enum. You know what? We're not gonna fight this. Let's just prove ourselves not crazy. And let's create a new key that's an integer. Squad formation. Because we know this works. This is gonna be integer based. And then back here in our strategize task, let's do kill this. Set value as int. And what we're going to do is we're going to do a random int. And this is going to be... Oh, wait. I didn't see that none in there. Was that the whole problem? Oh, it always said none. Okay, jeez Louise. Squad formation. Man, if that's all it was. I was just spelling it wrong. That's just gonna be a bummer. Squad formation. Okay, that's still single file, so that's not the only problem. Oh, rows with leader. Dude, that was the problem. Oh my god. Oh, but then it went back to single file. How did it do that? Oh, because he's changing his formation. Is he changing his formation each strategize step? Yes. Every time he strategizes, he's changing his formation. So what we don't want to do is in this strategize, if we go for our strategize type and we look at the formation, we need one more. We need to add an enumerator. And can we move it? And let's call this none. Okay, so what we're going to do in our strategize is we're going to get the value as an enum, and what we're going to get is a squad formation. And then if this is equal formation enum no. Yeah. Enum formation. Literal enum formation if it's equal to none. If that's equal. Ooh. Squad formation. Get value as enum. That's right. Byte to enum. Okay. Let's try this. That worked. Okay. So if that's equal to none, if that's equal to none, okay, we are going to set our enum to a random enum. And if it's false, then we're going to keep on rolling. So whatever we set our enum to start with should not change every time we come in to strategize. And if we feel like we want to change that later, we'll do that later. But for now, it's just what they spawn with is what they get. All right, let's just compile, save this, and wrap this up. I thought I was going to finish this like, I don't even know how long ago. All right, that's single file. So let's go again. Rows with leader. That's cool. They're all trying to get to their rows. When he strategizes, this shouldn't change. These should just stay rows with leaders the whole time. All right, so let's go one more time. Let's see if we can get a flying V in here. Single file. Rows with leader. Single file. Single file. Okay, so I'm wondering if our randomness is correct. Let's try 3. Line V, look at that. Okay, we're seriously wrapping this up right now, but before we do, just for fun, let's see if it's broken, see if everything we've got is right. Our squad sizes are 7 right now. Theoretically, we change our enemy spawner to be 21, we should end up with 3 squads, each of them with a random formation, and let's see if we can figure out what the formation is based on what the squads are doing. We got rid of that print. That's good. The formation enum, let's save that. Let's go back to our behavior tree, save this. Strategize, we shouldn't be, I think we were printing something in here. That's the squad ID. I'm not going to worry about that anymore. So save that. And then let's do a search in here for prints. There's one in here. Get the fallen position. Let's not do that anymore. All right, here we go. 21 enemies. We should get 3 squads. So we should have our pink, I believe our orange, and then maybe yellow. We got 2 rows with leader, and our yellows are doing it's hard to tell what our yellows are doing because we have 2, 4, 6, 8, 9, 10, 13, 14, 15, 16, 18, 19. I think we need some more yellows. So let's do a couple things. First off, let's go to our form up task. That's the get the fallen position. I believe we're not drawing in there anymore. So we're gonna come in here and we're gonna skip this draw. And then we'll come back here and let's just go crazy. Let's go 28. See what happens. We should no longer be drawing our spheres. So let's see if we can figure out what the pink guys are doing. Pink guys are single file. Orange, what is orange doing? Single file as well. And wait, they're all single file. There is no way that they all got single file. I mean, it's kind of cool looking, but that's not right. So pinks came in as a flying V. It looks like orange is rose. Yeah, orange is rows with leaders. Yellows are doing... Two, 4, 6, 8, 9 squad members in the Flying V squad. And then we got a green. One of our dudes must get blown off the map. How come we have 9 people in our pink squad? Okay, pink is single file. Orange is flying V, I think. Yellow is flying V as well. Nine people in yellow, 9 people in red. 2, 4, 6, 8, 9 in yellow. So our for some reason our squads are 9 deep right now. I don't remember making them 9 deep. So that time we had 2 flying Vs and a single file. Let's see what we get this time. This time we're going to get pinks look like rows with leader. Hard to tell. Okay, orange is definitely flying V. Pink is rows with leader. Yellow is rows with leader. Okay. Dude, I think that's cool. We are way beyond time, so I think we're gonna wrap this up. Let's escape this out and take a look at, thank goodness we were still streaming that whole time. Okay, so it's been a while since I mentioned it. If you are watching and you had questions, as I mentioned, this was a pre-recorded screen because I am out on vacation actually, and so I'm still around. I'm hopefully monitoring the chat. If you have questions, feel free to drop those in the chat. We'll try to get to those in the next session, and that will be, theoretically I should be back live Sunday night. And thanks for hopping in. I know this is a long one. I know it started to get kind of slow. There's a lot of math involved. It's also kind of late, and shouldn't be doing this so late at night, but we got some cool stuff done, man. It's just kind of wild to watch these dudes walking around the map and figure out what formations they're supposed to be in and what the leader's doing and all these kinds of things. I think we'll see, depending on where we got to in the last live stream, combined with this, we'll see what kinds of stuff that we want to take a look at come next Sunday. So in the meantime, thanks for checking out the video. And as always, hit me up if you have questions, right? Have a great weekend, everybody.